Hello everyone and welcome back. Today the world's data is expected to grow 61% to 175 zettabytes by 2025. According to research firm Gartner, around 10% of enterprise-generated data is created and processed outside the traditional centralized data center or cloud. By 2025, the firm predicts that this figure will reach 75%. The increase of IoT devices at the edge of the network is producing a massive amount of data. Storing and using all that data in cloud data centers pushes network bandwidth requirements to the limit. Despite the improvements in network technology, data centers cannot guarantee acceptable transfer rates and responses times, but it is a crucial requirement for many applications. Furthermore, devices at the edge constantly consume data coming from the cloud, forcing companies to decentralize data storage and service provisioning, leveraging physical proximity to the end user. And here is where edge computing is needed. The aim of edge computing is to move the computation away from data centers toward the edge of the network, exploiting smart objects, mobile phones, or network gateways to perform tasks and provide services on behalf of the cloud. By moving services to the edge, it is possible to provide content caching, service delivery, persistent data storage, and IoT management, resulting in better response times and transfer rates. At the same time, distributing the logic to different network nodes introduces new issues and challenges. This video will be a brief explanation of edge computing. If you are interested, continue watching the video till the end. Edge computing is a distributed computing system. A distributed system is a system whose components are located on different networked computers, which communicate and coordinate their actions by passing messages to one another from any system. Paradigm that brings computation and data storage closer to the sources of data. This is expected to improve response times and save bandwidth. It is an architecture rather than a specific technology. It is a topology and location sensitive form of distributed computing. Why do businesses use edge computing? Businesses use edge computing to improve the response times of their remote devices and more timely insights from device data. Edge computing makes real-time computing possible in locations where it would not normally be feasible and reduces bottlenecking on the networks and data centers that support edge devices. Without edge computing, the massive volume of data generated by edge devices would overwhelm most of today's businesses' networks, hampering all operations on an affected network. Scalable infrastructure costs are high. Slow services and high traffic networks led customers to take their businesses elsewhere. Valuable machinery could be damaged or simply be less productive. But most importantly, when networks get slow or get blocked, workers' safety could be compromised in industries that rely on intelligent sensors to keep them safe. Why is it important? More efficient operations. Edge computing helps enterprises optimize their day-to-day operations by rapidly processing large volumes of data at or near the local sites where that data is collected. This is more efficient than sending all of the collected data to a centralized cloud or a primary data center several time zones away, which would cause excessive network delays and performance issues. Faster response times. Bypassing centralized cloud and data center locations allows companies to process data more quickly and reliably in real time or close to it. Consider the data latency, network bottlenecks, and diminished data quality that could arise when trying to send information from thousands of sensors, cameras, or or other smart devices to a central office all at once. Instead, edge computing enables devices at or near a network's edge to instantly alert key personnel and equipment to mechanical failures, security threats, and other critical incidents so that swift action can be taken. Greater employee productivity. Edge computing enables businesses to deliver the data that workers need to complete their job duties as efficiently as possible, and in smart workplaces that take advantage of automation and predictive maintenance, edge computing keeps the equipment that workers need running smoothly without interruptions or easily preventable mistakes. Improved workplace safety. In work environments where faulty equipment or changes to working conditions can cause injuries or worse, IoT sensors and edge computing can help keep people safe. For example, an offshore oil rigs, oil pipelines, and other remote industrial use cases, predictive maintenance and real-time data analyzed at or close to the equipment site can help increase the safety of workers and minimize environmental impacts. Functionality in far-flung locations. Edge computing makes it easier to utilize data collected at remote sites where internet connectivity is intermittent or network bandwidth is limited. For example, a village in the countryside or a hospital in a remote location. Operational data like water or soil quality can be constantly monitored by sensors and acted upon when needed. Once internet connectivity becomes available, the relevant data can be transmitted to a central data center for processing and analysis. Security. For enterprises, the security risk of adding thousands of internet-connected sensors and devices to their network is a real concern. Edge computing helps to mitigate this risk by allowing enterprises to process data locally and store it offline. This decreases the data transmitted over the network and helps enterprises be less vulnerable to security threats. Data sovereignty. When gathering, processing, storing, and otherwise use customer data, organizations must adhere to the data privacy regulations of the country or region where that data is collected or stored. For instance, the European Union's General Data Protection Regulation, moving data to the cloud or a primary data center across national borders can make adhering to data sovereignty regulations difficult, but with edge computing, businesses can ensure that they're honoring local data sovereignty guidelines by processing and storing data near where it was collected. Reduced IT costs. With edge computing, businesses can optimize their IT expenses by processing data locally rather than in the cloud. Besides minimizing companies' cloud processing and storage costs, edge computing decreases transmission costs by removing unnecessary data at or near the location where it's collected. Edge computing hardware and networking. In edge computing, much of the processing power is physically located at or near where the data is gathered. Edge computing hardware often consists of these physical components. Edge devices include smart cameras, thermometers, robots, drones, vibration sensors, and other IoT devices. Some devices have built-in computing memory and storage capabilities, but not all do. Processors. Processors are the CPUs, GPUs, and associated memory that power edge computing systems. For example, the more CPU power an edge computing system has, the fast it can perform tasks and the more workloads it can support. Clusters or servers are groups of servers that process data at an edge location, such as on a factory floor or at a commercial fishery. Edge cluster servers are often tasked with running enterprise apps, enterprise workloads, and an organization's shared services. Gateways are edge cluster or servers that perform essential network functions like enabling wireless connectivity, providing firewall protection, and processing and transmitting edge devices data. Routers. Routers are edge devices that connect networks. For example, a router at the edge may be used to connect an enterprise's LANs with a WAN or the internet. Switches, which are also referred to access nodes, connect several devices to create a network. A node. A node is a term that describes the edge devices, servers, and gateways that enable edge computing. How does edge computing work? To make real-time functionality possible for smart apps and IoT sensors, edge computing solves three interrelated challenges. Connecting a device to a network from a remote location, slow data processing due to network or computing limitations, edge devices causing network bandwidth issues. Advancements in networking technologies like 5G wireless have made it possible to solve these challenges on a global commercial scale. 5G networks can handle vast amounts of data going to and from devices and data centers in real time. There is even a wireless network that uses cryptocurrency to encourage users to extend coverage to harder to reach areas. But advances in wireless technology are only part of the solution for making edge computing work at scale. Being selective about which data to include and exclude in data streams over networks is also critical to reducing latency and delivering real-time results. For example, a security camera in a remote warehouse uses AI to identify suspicious activity and only sends that specific data to the main data center for immediate processing. So rather than the camera burdening the network 24 hours per day by constantly transmitting all of its footage, it only sends relevant video clips. This frees up the company's network bandwidth and computer processing resources for other uses. What are some of the characteristics of edge hardware? Edge hardware needs to be durable and dependable. Often this equipment must be able to withstand extreme weather, environmental, and mechanical conditions. In particular, it often must be reliable, with reliability being key, especially in industries where equipment malfunctions can halt production and endanger workers. Edge hardware must be closed off from dust, dirt, moisture, and other matter that could compromise it. Temperature resistant. Edge hardware is often placed outside in freezing, sweltering, and wet climates. Sometimes it is even placed underwater. Being able to withstand sub-zero and near boiling temperatures is a must in many cases. Impervious to sudden movements. The hardware needs to be able to withstand vibrations and shocks by machinery or natural elements. Building these components without fans, cables, and other internal parts that can easily get shaken loose or broken is essential. Small form factor. With edge computers, the compact is the name of the game. They often need to fit into cramped spots. Examples including smart cameras placed on walls, shelves, and ceilings, and smart thermometers packed in shipping boxes. Equipped with ample storage, edge computers that collect vast amounts of data from edge devices can require significant data storage. They must also be able to rapidly access and transfer large quantities of data, compatible with new and legacy equipment. Edge computers, particularly those operating in production or factory settings, typically features a variety of input-output ports, including USB, COM, Ethernet, and general-purpose ports. This enables them to connect with both new and legacy production equipment, machinery, devices, sensors, and alarms. Built with multiple connectivity options, edge computers typically typically support both wireless and wired connectivity. That way, if connecting to the internet wirelessly is not an option at a remote commercial site like a farm or a ship at sea, the computer can still connect to the internet to transmit data, able to support several types of power inputs. Edge computing often supports a variety of power inputs to accommodate the wide range of power inputs they may encounter in remote locations. They also require surge over voltage and power protection features to help prevent electrical damage. Protected from cyber attacks, edge devices with often cannot be managed by network administrators as rigorously as their on-premises and cloud counterparts, tend to be more vulnerable to bad actors. To help safeguard them from malware and other cyber attacks, edge devices must be equipped with security tools like firewalls and network-based intrusion detection systems. Tamper-resistant. Because edge computing devices are often used in far-flung locations where they cannot be constantly monitored, they must be built to be kept secure from theft, vandalism, and unauthorized physical access. Edge versus fog. Fog computing allows data to be temporarily stored and analyzed in a compute layer between the cloud and the edge. For cases where it is not possible to process edge data due to edge equipment compute limitations, from the fog relevant data can be sent to cloud servers for longer-term storage and future analysis and use. By not sending all of the edge devices data to a central data center for processing, fog computing allows companies to reduce some of the load on their cloud servers, which helps to optimize IT efficiency. For example, consider a building management company that uses smart devices to automate temperature control, ventilation, lighting, sprinklers, and fire and security alarms in all of its buildings. Rather than having these sensors constantly transmitting data to their main data center, the company has a server in each building's control room that manages immediate issues and only sends aggregated data to the main data center. When network traffic and compute resources have excess capacity, this fog computing layer allows the company to maximize its IT efficiency without sacrificing performance. It is important to note that edge computing is not reliant on fog computing. Fog computing is simply an additional option to help companies gain more speed, performance, and efficiency in certain edge computing scenarios. I hope today's video was useful. Thank you all for watching. Stay tuned to the next video.